All right, we're going to do example 2 together, and I'm going to teach you how to graph it a little differently than the book teaches you. What I teach is we're going to first find the vertex. And as you learned before, the vertex is either the highest point or the lowest point of the graph. The x value of the vertex is an equation that we are going to use very often. Okay, stop the video at any point to catch up on notes. The x value of the vertex is x equals negative b over 2a. Or we could refer that as the opposite of b over 2a. So when we look at our equation, g of x equals 2x squared, we're thinking that as a quadratic in the form of y equals ax squared plus bx plus c. In the examples we do today, c will be 0 in all of the examples. So let's go ahead and identify a, b, and c. In this example, a is 2, b is 0, and c is also 0. So when we're finding the vertex, the x value of the vertex, x equals the opposite of b, where b is 0, so the opposite of 0 is just 0, 2 times the value of a, which is 2. Okay, and that gives us x equals 0, or I'm sorry, x 0 over 4, which is equal to 0. So the x value of our vertex is equal to 0. To find the y value of the vertex, we substitute whatever we got for x, in this case 0, into the equation. To find y. Okay, so our equation is y equals, or g of x equals 2x squared, y equals 2 times 0 squared, y equals 0. So our vertex is 0, 0. Okay, and I can plot that point at 0, 0. Remember what you learned about the axis of symmetry. The axis of symmetry is sorry, my line is not straight, but it's a vertical line through the vertex. The x value of the vertex also gives you the axis of symmetry. So our axis of symmetry, I'm going to call it AOS for axis of symmetry, is x equals the x value of the vertex, x equals 0, because this is a vertical line through x equaling 0. So now we're going to find more points on that graph. Okay, so we're going to make a little table. We already know that when x is 0, y is 0, that's our vertex. So let's find some points on the right side of our vertex. All right, we can use any x values that we want. I use the x values closest to the vertex to begin. So let's go ahead and find our y value when x is 0. To do that, we're going to take that x value and we're going to go ahead and plug it into our equation. Okay, so 2 times 1 squared, y equals 2, and that's going to be another point on our parabola. Okay, I'm going to use the next x value closest, 2, and I have y equals 2 times 2 squared. Okay, 2 squared is 4 times 2, so when x is 2, y is going to be 8. Okay, I need to find the points on the other side of my axis of symmetry, but I don't need to do the math all over again. Remember, the axis of symmetry splits our graph in half, so we have two symmetrical sides. So my point here at 1, 2, I can reflect it over the axis of symmetry. My point at 1, 2 is 1 unit away from the axis of symmetry. It's going to be 1 unit away from the axis of symmetry on the other side. My point 2, 8 is 2 units away from the axis of symmetry. It's going to be 2 units away from the axis of symmetry on the other side. Okay, because again, the axis of symmetry splits our graph in half. I'm going to draw a smooth curve, and there's my parabola. Okay, so the x value of the vertex gives us the axis of symmetry. The y value of our vertex gives us our lowest point or our highest point. So our lowest point on our parabola is called the minimum, and our highest point is called the maximum. Okay, and that's the y value of the vertex. You can see in this example, because our graph is opening up, we have a minimum value. Okay, in this case, the minimum value for y is going to be 0. We have our axis of symmetry. You can also find your domain. Okay, you can see that there are no restrictions on our x values. Our graph is going to keep going forever. It's going to keep getting expanding wider and wider. So therefore, our domain is all real numbers. Our range are possible y values. If you look at your graph, our y values start when x is 0, start when y is 0, and they increase from there. So our range is going to be y is greater than or equal to 0. All right. And lastly, we're going to compare to the parent function. In the last video, you learned how to compare looking at the a value. The a value for your parent function is 1. And the a value in g of x equals 2x squared is 2. So when we're comparing, we would say that our graph is a vertical stretch by a factor of 2. Okay, and we're done. So we graphed, we found our vertex, we found 2 other points, and we reflected them over the axis of symmetry. We saw that our graph had a minimum because it opens up, and our minimum value is 1. Let's write that, or no, I'm sorry, our minimum value was 0. Okay, we just write that as a number, so our minimum value is 0. And it's a vertical stretch by a factor of 2.